All right, difference of two squares. Again, this is something that can save you a little bit of time if you're able to take a little bit of what you're working on, and if you're able to just kind of tell that those are perfect squares, then you're going to save yourself a little bit of time. Typically, when you have two terms, you want to look for difference of two squares. So you want to check if the first term is a perfect square and the second term is a perfect square and it's a difference in between. That's a big hint, difference of two perfect squares. And the difference of two perfect squares always breaks out into your two factors. One of them is always positive and one of them is always negative. The reason for that is when you FOIL these two out, you need that middle term to cancel. No middle term there. It's missing. So if I prove that to you, a plus b times a minus b, if I FOIL, I get a squared, then I get negative ab, then I get positive ab, and then I get negative b squared. Every single time, if one term is positive and one term is negative, those middle terms are going to cancel. We get a squared minus b squared. So whenever we have the difference of two squares, we can always factor it down to a plus b times a minus b, and we don't have to really think about it. So the first thing you do, again, is what we were doing with our perfect square trinomials, figuring out what the square was. The square root is 16. So what times itself gave you 16? It was 4. And what times itself gave you x squared? It was x. So that's your a term. Okay? And then what times itself gives you 36? The answer is 6. So we would verify that the sign is subtraction, the difference between them. We did that. We verified that it was a subtraction symbol between the two. And then you break it down using the pattern. So a plus 6 and a minus 6. And then this would be your answer. A plus 4x plus 6 and 4x minus 6. A plus b times a minus b. Okay? So you factor down the difference of two perfect squares. This should not be here. Let's cross this out. I think that just got copied and pasted there somehow for whatever reason. So scribble that out. That's not supposed to be there. So factor using the pattern, you would just say a plus b and a minus b. There you go. That's better. All right, let's try it. Difference of two squares. Is that a perfect square? Yes. X times x. Is that a perfect square? Yes. 8 times 8 is 64. Is this a difference? Yes, it is. So that is a difference of two squares. So it's going to be 1x plus 8 and 1x minus 8. One is positive, x plus 8. One is negative, x minus 8. Breaking down the difference of two squares is super easy. Just figuring out what the roots were, and one's positive, one's negative. So let's look at number 2. What times itself gave you 4? 2. What times itself gave you x squared? X. What times itself gives you 49? 7. And that is a difference between them, and they are perfect squares. So 2x plus 7 times 2x minus 7. All right, number 3. What times itself gives you 4? 2. What times itself gives you x squared? X. What times itself gives you 25? 5. And yes, it's a difference. So the pattern is 2x plus 5 times 2x minus 5. Does it matter whether the first one's positive and the second one's negative, or the first one is negative and the second one is positive? No. What matters is that one of them is positive and one of them is negative. So if you're reading them in the opposite order, that's fine. What times itself gives you 36? 6. What times itself gives you x squared? X. What times itself gives you 81? 9. They are a difference. So difference of two squares breaks down to a plus b times a minus b. 6x plus 9 times 6x minus 9. So you have one of each. Okay, difference of two perfect squares.